Go ahead and pull up, please, your 4.6, graphing the other trig functions. We're going to talk today about tangent. We're not going to do cotangent. It's in modules. And then we're going to do our cosecant and secant. Very, very, very. Tangent's very basic. And then cosecant and secant are exactly what we did yesterday. You'll see how it's a touch different just with the graph. But, okay, here is your parent function for tangent. Okay, you guys see your parent function for tangent. Notice the graph of your tangent function. Do you see the graph in here? It resembles a cubic function, right? This is a positive cubic function. I'm going to call it a snake. It's not a cubic function, but the way the graph looks. If it was negative tangent, it would just slope the opposite way. It would slope like it was a negative line, you could even say. But when you talk about tangent, we're not going to talk about shifting it left and right, up and down. So it's super basic when we talk about tangent. What you need to remember with tangent, every single time you guys are going to graph tangent, you have to find 4 asymptotes. What are asymptotes again? They're like boundary lines that your graph gets real, real close to, but doesn't do what? Doesn't touch. You're going to find 4 asymptotes, and then we'll call them 3 snakes. That's the graph itself. Okay? In your parent function, your asymptotes are at negative pi over 2 and positive pi over 2. Okay, that's with your parent function. So I'm going to show you how, when you're not graphing the parent function, how that you can find where to put your asymptotes.
So it's always pi over 2?
This is, yeah, we'll just watch for a sec. This is with your parent function, right? You have an asymptote here at pi over 2. See that? You got another one here at 3 pi over 2, and it would just continue on. You know, those little snaky things in the middle. If it was a negative, the snaky things would go backwards. But every time you graph a tangent function, you guys are going to find 4 asymptotes and 3 snakes. That's what I'm going to be looking for. All right, so let's move along. I'm sorry, I forgot to do the bottom one. All right, sketch the graph of tangent by hand. For tangent, you do not have to find A, B, C, all that stuff. You only have to do that for sine, cosine, and their reciprocals. For tangent, the only thing we're concerned about are our asymptotes and the direction of our graph. The way that you figure out your asymptotes and the direction of your graph. Whatever is with x, you set equal. This is to find asymptotes. Find asymptotes. And how many do we need? 4, right? Originally, you're going to be able to find 2 of them right at the beginning. You take whatever is equal to x and you set it equal to pi over 2. And what else do you think? Negative pi over 2. There you go. Whatever is with x, if there's nothing there, then it would just be x equals pi over 2 and negative pi over 2. So if we're going to solve this teeny tiny little equation, you guys agree with me we can cross multiply? So I get 2 pi equals 2x. Divide both sides by 2, and x equals what? Okay, one of my asymptotes is at pi. Same thing on this side. I'm going to say negative 2 pi equals 2x, divide by 2, and I get another asymptote at where? Negative pi. Okay. I told you in order to graph, you need the shape of your snakes, 3 of them, and you need asymptotes. Yeah?
Why does it go from pi equals x over 2 to pi over 2?
We cross multiply? 2 times x is 2x, and then 2 times pi is 2 pi, and then just solve for x. So if you're going to graph, go ahead and set it up. All right, you're going to have an asymptote. I'm going to say this is pi. And you're going to have an asymptote at negative pi, right? We already found that? Remember, our asymptotes are dotted lines. They're boundary lines. Now, I told you need to find 4. We've already found 2. To find the other ones, all right, they have to be equidistant apart. What does that mean? Equal distance. How far is it, guys, from negative pi to positive pi? 2 pi, correct? So then this asymptote over here on the right has to be 2 pi away. So if I'm at 1 pi and I add 2 pi, where is that going to be?
3 pi.
Yep. You have an asymptote here at 3 pi. And then if I go to the left, if I'm at negative pi and I go left 2 pi, what do I end up at? Negative 3 pi. Perfect. There's our 4 asymptotes. And now what do we need? 3 what? 3 snakes. Is this a positive function or a negative one? Positive. That means it's going to resemble a positive snake or a positive line. So the way that you would draw this, guys, a little snaky thing here in the middle. You get close to the asymptotes, but don't touch them. And that's it. That's your tangent. Now, if there's a number in front, hang on one sec. If there's a number in front, like 2 or 1/2, all that is a vertical stretch or a shrink. So that would make your snakes a little taller, skinnier, or a little shorter, fatter. But we're not going to have to worry about phase shifts and vertical shifts up and down with tangents. Your phase shift will come when you find your asymptotes. It'll just move them, but mathematically we'll do that. Yes, sir.
So, like, miss, how do we know, like, you know, like, how do, so, you know how, like, it crosses the x-axis?
Like exactly where? Don't worry about that. You don't worry about finding the exact intercept. All right, let's look at the next one. Oh, wait, no, I don't. It says sketch the graph of -3 tangent 2x by hand. First thing I notice is what? It's a negative. So instead of a positive snake, my snake is going to go like that. Just the opposite direction, okay? Direction's very important. Now, what are the 2 things you have to find in order to graph? 4 asymptotes. 4 asymptotes. And 3 snakes. Good. Now, with this 3 in front, it doesn't shift my graph anywhere, left, right, up, or down. All it does is just make my snakes a little skinnier. It's like pulled up. It's a vertical stretch. That's it. But how do I find my asymptotes? Where do I figure out where to put my boundary lines? I take what's with x, correct? And I say, okay, fine, 2x equals positive pi over 2. And 2x equals what? Negative pi over 2. Perfect. So again, can I put this over 1? All right. If I have a fraction equal to a fraction, how do I solve it? Cross multiply, right? So I have pi over here equals 4x. Divide both sides by 4. So this asymptote over here is that x equals pi over 4. Multiply here, cross multiply. I get negative pi equals 4x. Divide by 4. And I get an asymptote here at negative pi over 4. What do you guys notice about your asymptotes?
They're just opposite.
Yeah. So here's my asymptotes. I have 1 at positive pi over 4. And I have 1 at negative pi over 4. Now here's where we have to do a little bit of thinking. Right? Remember, they are dotted lines. This is where you have to do a tiny bit of thinking with tangent. Your asymptotes have to be equidistant from each other. That means what? Equal and distance the same. Guys, how far is it from positive and negative pi over 4? What's the distance? What's pi over 4 plus pi over 4? 2 pi over 4, which is pi over 2. So what do you have to add to each one of your asymptotes? Pi over 2. Does that make sense? So if I say pi over 4 plus pi over 2, my common denominator would be 4. This becomes a 2. So I end up, my right-hand asymptote is where? What's pi plus 2 pi? So 3 pi over 4. Okay. So I have one here at 3 pi over 4. And then if I'm going to go the other direction, I have to go left pi over 2. So that would be,
Negative 3 pi.
yep, negative pi over 4 minus 2 pi over 4, which gives me negative 3 pi over 4. Good. Okay, so that's the hard thinking we had to do with tangent. Not bad. Now, the last thing we do is that we have to draw our three little snaky things. What direction should my snaky things go?
Down.
They should be starting up in the corner and going downward. So you want to have a nice little squiggle. It's not a straight line. It's not a line like this or something like that. It's like a cubic kind of function line that gets close to the asymptotes but doesn't touch it. All right, tangent's super basic. We okay? All right, look at it for a minute. Let you guys finish up. All right, cross off cotangent stuff. Yeah, whoops. Don't need to worry about it. We're now going to talk about reciprocal functions. Everything we did yesterday is exactly what we're going to do, except one little difference with the graph. Reciprocal means what? Opposite. Okay. When we talk about graphing, I'm going to say reciprocal means, we'll say flip or opposite. That's fine. You'll see what I mean in just 1 second. All right, first thing we're going to do is we're going to identify this function and its reciprocal. What is the reciprocal of cosecant?
Sine.
Sine, okay. Remind yourself, guys, where does sine start? At the axis or at the amplitude? X-axis. Okay, good. All right. Now we're going to do everything we did yesterday. We're going to identify our A, our B, our C, our D, our starting point, time period, and what's the last one? Our increments. Good. That's all right. How far we're going from one to the next. So A, remind yourself, A is the amplitude. It's the number in front of your function. What's the highest and the lowest this goes? 2. Yep. Up 2, down 2. B is the number in front of your x value. What is the number in front of x? 1. C is our shift, left and right. Where is this moving? Left pi over 4. So how mathematically would you say left pi over 4? Minus pi over 4. Perfect. And then D is our vertical shift up and down. We adding or subtracting here? No. 0. We're going to practice that a little bit more tomorrow and Monday. So now the most important information we can find right now is our starting point, our time period, then our increment. So how do we find the starting point again? What do? C over B. So my C value is negative pi over 4. My B value is 1. So I'm starting at negative pi over 4. Everybody with me? Okay, my time period. Remind me again how to find time period. It's 2 pi divided by B, right? So it's 2 pi divided by 1, which is 2 pi. Why is that important? Why is it important to find the time period? What do you have to do with that? You got to do what? Tell me again. You have to divide it by 4. 2 pi divided by 4 gives me my increments. How much am I adding? How far away is each point? It's going to be what? Pi over 2. Whoops. So you're going to add pi over 2 each time. Now, nothing that we just did right now is different from yesterday, right?
Correct.
Okay, correct. So let's get it all set up. Show you why this is a tad bit different, and it's not anything you guys can't handle. Again, you'll be given this on your test. What is very important about where I place negative pi over 4? Where is negative pi over 4, guys? It's on the left, okay? Put it over here. It's got to be to the left of the y-axis. That's what's important. So now we're going to find these other pieces. So I got 1, 2, 3, 4. Now, how do I know what the next tick mark is going to be?
Adding pi over 2.
You're going to add pi over 2. We're just going to add pi over 2 a whole bunch. So I'm over here, negative pi over 4. It's too big. Negative pi over 4 plus pi over 2. Common denominator. This is 4. This is 2. What's negative 1 plus 2? So this is pi over 4, yeah? Yes? Okay, so now I'm going to take pi over 4, and I'm going to add another pi over 2. Well, pi over 2 is just the same as 2 pi over 4, correct? So where's my next tick mark? At 3 pi over 4. Okay, good. So I take 3 pi over 4, and I add another. Are you guys okay with me saying 2 pi over 4? Okay. And I get what? 5 pi over 4. Okay, perfect. Whoops. And then I'm going to take 5 pi over 4 and add another 2 pi over 4 and get 7 pi over 4. All right, it's exactly what we did yesterday. You guys did awesome. Very good.
Is there a difference between them?
Okay, guys, the difference in how to graph the cosecant and your secant equations are as such. We're going to graph with a dotted line our original function, which would be sine. So sine starts at the x-axis. It's going to go as high as the amplitude. Our amplitude is 2 up here and negative 2 down here. And it's going to go from negative pi over 4 up here. It's going to come down, hit the x-axis again, down to the bottom amplitude, come back to the x-axis. So the way that you draw your cosecant curve is you use the points that are at the x-axis on the original curve as the little boundary lines. And what your cosecant curve is going to be is the reflection of the original sine. So if you see here, you have your original sine curve here. What we're going to do is reflect it above here. And it's important to make attention to this point right here is in common with it. So you can't just draw it up in outer space. It has to be attached because all you're doing is reflecting that little part of the curve that looks like a parabola. Same thing here. We have this curve here. What we're going to do for the cosecant is we're going to reflect it down here. So everything that you do for your sine and cosine are exactly the same. Just when you go to graph it, you reflect the areas that are in between the points on the x-axis. So here, when we go to do secant, again, it's the same thing. We're going to find A, B, C, D, our starting point, our time period, and our increments. Now, I like to start off everything that we do to graph, and I say, okay, secant. Well, secant, the reciprocal is cosine, so I remind myself, oh, okay, I'm going to start at the amplitude. I just think that's a good habit to get into. All right, guys, so if I look here, I'm going to determine my A value. Remember, A is your amplitude. It's the number in front of your function, so it's 1. It's a positive 1, so we don't have a reflection. B is the number in front of your x, so that's our 2. C is our phase shift, left and right. Did we add or subtract anything? No, so it's 0. And then D is our vertical shift up and down, and we're not moving it anywhere, so it's 0. So we're going to find our starting point, which is C divided by B. So I'm going to take my C term of 0 divided by B is 2. So I'm starting at the origin of 0. My time period is 2 pi divided by your B. Well, I have 2 pi divided by my B value is 2. So my time period is pi. And the reason that's important is because you have to find the increments. You have to find the space between each point. So you're going to take your time period and divide it by 4. So we're going to say pi divided by 4. So what you're going to do is add pi over 4 to each area on your graph. And we're starting where? At 0. So I'm going to start here at 0. And then I have my tick marks. 3, 4. My first tick mark, if I say 0 plus pi over 4, I'm at pi over 4. So if I take pi over 4 plus pi over 4, I'm at 2 pi over 4, which is pi over 2. So then I'm going to say pi over 2, which is 2 pi over 4, plus pi over 4, gives me 3 pi over 4. Then I add 3 pi over 4 plus pi over 4, and that's going to bring me right here to pi. So what we're going to do, write our amplitude. We're going to graph our original cosine curve in a dotted line, and then we're going to graph the secant, which is the reflection of that, and that will be our answer. So remind yourself, guys, cosine starts at the amplitude. I'm going to start at positive 1. Come down here, and we're here, here, and here. So it looks something like this. Here's your original cosine curve. And then remember, we're going to use our boundary lines are going to be the points at the x-axis on our original curve. And we're going to reflect. So you take the point that they have in common. So I have this piece right here. I'm going to go ahead from here and reflect it upwards. So here would be the common point that they have. I have this parabola looking thing. It's not a parabola, but that's the part of the curve. So I'm going to reflect it down here. And then again over here on the right, here's the point that they would have in common. So I'm going to take this piece of my curve and I'm just going to reflect it upwards. And then in pink would be the graph of your secant curve. All right, last slide here just shows the library of functions. It talks about what the sine, cosine, tangents, and their reciprocals look like to just kind of give you guys an idea and a picture in your mind. So we will practice more of this tomorrow in class and Monday in class, and you guys will have your test on Tuesday.